All right, let's move this over here. Let's get it out of the way. Let's put it over there. Lesson 31, multiplying and dividing rational expressions. Well, what is a rational expression? What is a rational expression? I don't know. Maybe. Oh, it's a fraction. Yeah, look at that. It's a fraction. It's a rational expression. Yeah, okay. So we all remember how to multiply fractions, right?
Yes.
How do you multiply fractions? Numerator times numerator, denominator times denominator. How do you divide fractions? If you had, let's just get us a fraction up here. Let's divide 3. Ooh, I don't like that color. Let's get a bright color. 3/8. Let's divide that by 1/4. So how do we do that? Well, same change. We were dividing. Now we're going to do what? Times, and now we flip this 4/1. And now we've got a fraction times a fraction. So 3 times 4. Well, can we simplify this before we multiply? I think we can. 4 goes into 8 2 times. So 3 times 1 is 3, and 2 times 1 is 2. So there's our answer, 3/2. 3/8 divided by 1/4 is 3/2. Golly, I wouldn't have thought that a fraction, that's a little bitty number divided. Oh, it's divided by a little bitty number. So how many of these are in there? Where's 1.5 of those in there? Okay, so multiplying fractions, there we go. We've already done that. What is that? What is that, 6/35? Will that reduce? I don't think so. Okay, dividing fractions. Remember, that's what we did. We got this, and then we turn it over, and what? 4 times 1. 24/7. Okay, same change, flip. I've heard that before. Well, how are we going to do this? Well, here's a rational expression. It's a fraction. Well, how are we going to do this? Well, we multiply numerator times numerator, denominator times denominator. But before we do that and get a big old numerator and a big old denominator, why don't we cancel some stuff out? Can't we do that? Yeah, we can. Let's see. I can cancel this a right here into that a right there. I can cancel this b squared right there into this b squared. I can cancel this b squared into 2 of these b cubes. Okay, so that just leaves b to the first power. Let's see, I can cancel the 6 into the 12 and get a 2. Boy, this is going to be simple here. So I think that's all far as I can go. All right, so I got 5 times 2, which is 10. No variables. A squared over, what's left here? 1 there. So 3b. Huh, well, that was pretty simple. Okay, let's divide these. Remember how we divide fractions? Yeah, we flip. So we got 5ab squared over 6b squared times 3ab cubed over 12a squared b squared. Now let's cancel some stuff if we can. Cancel 3 into the 12. Let's change color so we can see it a little better. 3 into the 12 4 times. We can cancel, let's see, we can cancel the b squared into b squared. Cancel this a into one of those a's. Make that a 1. Then we can cancel this other a into that a. Gets rid of that. Let's say we cancel a b squared into a b cubed and get b to the first. And I believe that's all we can do. So we've got what? Ready to multiply now. 5 times b, 5b. 6 times 4, 24. I don't have any variables, so that's my answer right there. 5b over 24. Let's draw that over a little further there. Okay, all right. Okay, wow. Here's one that's complicated here. Well, is this a fraction? Well, yeah, it could be. How can we make that a fraction? We just put it over 1. Now it's a fraction, right? Right, Mason? Okay. So maybe we can cancel some stuff out before we start multiplying here, because what we're fixing to do is if we start multiplying now, we're going to get big old number over a big old number, and more than likely we're going to mess up. So let's see if we can factor first. Remember, what did we do on this previous one here? We canceled out some factors. Let's see if we can cancel some factors here. Well, this x plus 4 has no factors. So let's just write x plus 4. Let's put it in parentheses, though, as a factor. Can we factor the denominator? Yeah, we factor x out. And this leaves x minus 4. Okay, can we factor this? I don't know. Let's see. Maybe we can factor it into two binomials. Well, the first one's going to have to be 2x, and the other one's going to have to be an x. And let's see, this is a minus. And then we have to look at this. This is a minus. That means both these should be minus, right? And now Allison, let's see if we can use a little insight here and sort of figure out what these numbers might be. What are we trying to accomplish here? We're trying to cancel some factors. Well, x is not going to be a factor up here to cancel. I can't cancel anything here. Maybe this one is going to be x minus 4. Maybe, just maybe. Let's try that. Well, 4 is a factor of 4. So let's put a 4 there and a 1 there and see what happens. Let's test it out here, Cody. How do we do it? By 4. 2x times x is 2x squared. Outer, 2x times minus 4 is minus 8x. Can you keep up with that? Minus 8x? Minus 8x. That's right there. It's minus 8x. Okay? And then minus 1 times x is minus x. Well, I already got minus 8x. Now I got minus 1 more x, right? So how many minus x's do I have now? Minus 9x. Look at that. Minus 1 times minus 4 is plus 4. So now I can cancel this factor. Let's change colors. Cancel this factor into that factor. It's really still over 1 here. So now we can multiply this factor times that factor, and then our denominator is just going to be x. Okay, so we want to do that. How do we want to do that? By 4. 2x squared, first times first, outer times outer, minus x, inner times inner, plus 8x, and then last times last, minus 4. Well, we got some terms here that we can add because they're like terms, so we get 2x squared plus 7x minus 4 over x. That's our answer. Okay, so let's see what's on the next page. Oh, well, look at that. There's the homework. Look at that. Homework. Lesson 31, 2, 4, not 2 through 4, 2, 4, 6 through 10, 13 through 16, 21 through 23, 28, and 29. And
hey, Trent.
Hey, Trent.
bye, Trent.